Bob, take it away. We're online.
Okay. Hi, everyone. This is the meeting of the Warren Astronomical Society. Some people are at Cranbrook, some people aren't. And so tonight we have elections hosted by the inimitable Mark Kedzier. Our main talk will be Solar Cycle 25 by Rik Hill, actually a redo, hopefully with less technical problems. So I don't know if we have any first-time attendees there, but if there are, you can you can join or renew your membership with David, who should be at the front of Cranbrook there. Members get a name badge and lanyard. As a tradition, we like to go through the ranks at Cranbrook and do a roll call and see who's there in the audience. And I wish, since I am here now, I wish I could see the audience. So I'm going to have to do something about that. But anyway, go ahead and do the roll call there at Cranbrook.
Okay, this is Dale Parton, first vice president.
Dale Jamie, publication. David Ransky, treasurer.
Michelle, publication.
Mark Kedzier, Jeff McLeod, outreach. Mike Conwell. Mike Conwell also. Tom Ferdinand. Jack Brisbane. Donnie Spilo. Ken Lord. Ben Riley. Kathleen Russell. Sorry. Jim Wallace. Charles Strackbine, secretary.
Peter Wong, card carrying member.
Dave Noble.
Yeah.
Diane
Hall.
John Kincaid. Reverend Rasmussen.
Okay, well, welcome everyone.
Wow, good crew. All right,
Do we have any new people here tonight? Wow, welcome.
We do.
How did you hear about this group?
I heard about it on the internet, and I just wanted to get a telescope and get into it. I used to do it when I was a kid, and I figured I need more information first before I make a decision.
Wise man there. Yes, you need more information before you buy a telescope.
Yeah.
Okay, great.
We've got plenty of members who'll be more than happy to let you look through their scopes.
Right. Welcome.
All right. So, WASP wearables are available from Mark Kedzier. You can check to see what's available in our newsletter. WASP stickers are available with David at the front. The club is a member of the Great Lakes Association of Astronomy Clubs, and they host the Astronomy at the Beach event. They have a meeting every second Tuesday of the month, and if you'd be interested in helping plan and run Astronomy at the Beach, they'd love your help, and they're going to need some officers come January. So, officers' reports. Wow, Dale, what a great picture on the cover of the newsletter. I absolutely love it. Our banquet is Thursday, December 4th. There is a full page spread in the newsletter about that. We need 35 people to cover expenses, and we could also use some suggestions for awards. So if you have any suggestions for people that are deserving of an award, let the board know about that. The board has been talking about adding some verbiage into the bylaws about essentially board members getting a free membership. And Jeff McLeod definitely did not use AI to create some legalese. And we are supposed to present that to the membership. Do we want to do that now, Dale?
Yes, could you read it?
Yes, all right.
Display it somehow while you're reading it?
Yeah, I can share this. Down to the bottom. Share that. All right, can you see that?
Yes.
All right. So this is a written amendment to our bylaws. It's been submitted by Jeff McLeod to the secretary. The board of the directors shall read the amendment, like I'm doing, and vote at the board meeting, which we did. Then read to the membership, which we're doing. Membership votes at the next meeting, so Cranbrook, December 1. So Jeff McLeod submitted this. Anyway, the bylaws. Section 7.05 compensation of employees. The directors of the corporation shall serve as such without salary, but the board may authorize the payment of reasonable expenses incurred by the directors in the performance of their duties and reasonable compensation for special services rendered by any director, except as provided in this section. No officer or trustee of the corporation shall receive directly or indirectly any salary or other compensation from the corporation. And section 705A, waiving of directors' membership fees.
Which is the new part.
Yeah, in recognition of the time, effort, and services rendered by members of the board of the directors in carrying out purposes of the corporation shall waive the annual membership dues for each director during their term of office. This waiver shall be considered a form of reasonable non-monetary compensation for services rendered, consistent with section 2.2 of these bylaws and applicable provisions of section 501c3 of the Internal Revenue Code. Such waiver shall not affect any other rights or privileges of membership, and the directors shall be considered members in good standing for all purposes of these bylaws. The whole thing is board members get their dues free. So
Can I
we're going
comment,
to
Bob?
Sure, but go ahead.
Just to say, we had, as part of our bylaws, we have to read any proposed amendment to the bylaws to you guys, and then vote. You will vote at our next Cranbrook meeting, up or down on this proposed amendment. Yes,
Since this is the member notification area, we can still make changes now, right? Because the word waiving is waiving as in, you know,
Yeah.
elbow, wrist.
okay,
wrist.
waiving is spelled wrong.
Yeah. Need to add an I in there, I think.
Yes.
ChatGPT.
I think this is why we have you guys look at it.
Yeah, your correction.
Don't remember it being spelled that way.
Yeah.
No, we are literally waving.
We will,
Apostrophe after directors as well.
All right, it doesn't, okay, this does not change the spirit of the amendment. I think we can still vote on it next meeting.
Yes.
Those changes.
We left out a character. All right. So stop that share. Alrighty. So that is done. Let's get back over to this thing. All right, so yeah, that was fun. All right, so our astrophoto calendars are available. Dale should have them up front there. And Connie and I will be attending WindyCon this weekend. That's a science fiction convention in Chicago, and the one where I met Brother Guy in the 1980s. And so it is the 50th anniversary of General Technics, which is the science fiction techie club that I'm a member of. And so we're going to I haven't been to one of these things since 2019, so and I'm really looking forward to it. So Dale, what you got going with First VP?
wow,
You angle your camera up a little. There you go. Hi.
hello. We really need speakers for our presentations. Most especially, I need speakers who can give a short presentation, 10 or 15 minutes kind of thing. So if you have any inkling of something you could speak on, please let me know at the break, okay? I will also tell you, well, Vachalia is messing around here, that at our next meeting at Macomb, Bob Tremblay, our current president, is going to speak on the interplay of science fiction and astronomy. That's a favorite topic for him. Then when we're back here a month from now at Cranbrook, Tom Hagen is going to give a short presentation on radio astronomy. And then Buddy Stark is going to have the main presentation on Brahe and Kepler. Those are the two guys who each contributed toward finally figuring out how the planets actually move around the sun. So that's what's coming in our next two meetings. Back to you, Bob.
All right. Thank you. Also, if you're interested in giving presentations, GLAC member clubs had said they would be interested in having speakers from the WAS speak at their club. So if you've got a lecture that you'd like to give, you can give it at like 7 different places. So Riyadh, what is going on with the observatory?
I'm trying to remember, can be heard, so.
Okay. Hello, everyone. Last open house we had on October 25th. We started out about close to 6:30 in the evening. And we started out kind of cloudy. The sky was cloudy, but it cleared up right around sunset. So we had a really good evening. We observed a lot of objects, including the moon, Saturn, Uranus, Neptune. We also looked at, we found the comet Lemon. We saw that also with the scope that we set up outside the 10-inch Dobsonian. So Ken Lord helped with that. We also had a lot of help we had some scouts, so we had help from Bob Berta. He was out there, and also we had some help with the crowds from I guess with Tina. She was helping out, giving out handouts to them. So we were able to observe a lot of objects. We used also the 8-inch refractor as well, looking at deep sky objects and double stars. So we've had a really good evening, and we've lucked out this year. A number of occasions, open houses have been clear. I think we've had maybe a couple of them that were completely clouded out, but in general, it's been pretty good this year. So next open house is November 22nd. We're going to start at about 5:30 because of the time. I'll probably be there around 5 o'clock anyways, if you want to show up a little earlier. And as usual, if it's cloudy, I'll be there for at least 2 hours unless people show up. And if it's clear, we might be there till midnight or so. Last open house, we were there till about 11:50 when everybody left. So hopefully we'll see everybody at the next open house. Thank you.
Thank you, Riyadh. All right. Treasurer David, what is going on with the Treasury?
How are we hearing you through this microphone?
The speaker's not working. This mic is not working.
Okay.
All right, for the
Hi
treasury
there.
report. In the treasury, we have 20,289. There's no balance on the credit card, so yay. PayPal, we got about $54 in there. Our cash box, we have about $180 plus change. That's it.
All righty. Secretary report. Charlie, what is going on with you and Stargate? Anything new on Stargate?
Hello, my name is Charlie Strackbine, and I'm the secretary of WAS here. And the meeting notes are in progress. That's the biggest part of the job. We sent out the beg letters on the 21st October, and we got 2 back because the addresses were wrong. But we do have the updated addresses, and those beg letters will go out tomorrow. And the Stargate idea, the Stargate ideas are coming along. It's been difficult to find. Well, I've just got some recent information from Mark Kedzier here that should help us out with a couple existing vendors. So that's it for now, and thank you.
All right.
Yeah.
All right, Jeff, outreach. And I do have to say, I was I was scheduled to be at this MISD event on the 8th, and I'm going to be in Chicago. So if somebody wants to take my place at the table at that event, I can get you the standees and the table stuff.
Bob, do they know that you're not gonna be there?
Not yet. They will.
Do me a
Also,
favor and let them know.
we have a event at Cranbrook on the 15th. Or there is an event at Cranbrook on the 15th. They
You
want
wanna
to
do the rest of the outreach report while you're
No,
at it?
I'm sorry. Go ahead.
All right, so in previous stuff, Mark presented at the Nat branch of the Detroit Library. What was the date of that? 28th. On intro astronomy, astronomy as a hobby, telescopes, all that kind of good stuff. Did I do anything? I don't think I did. I think I passed it off to, I did? What did I do? Oh, I guess really early in the month, I also presented at the Detroit Public Library, Nat branch on, the moon is not boring. Yeah, and then we looked at the moon. That was a good night. Bob is correct. We have some upcoming things. So November 8th, Macomb Reads at the MISD Education Center up Hall Road is having like a huge event, like 2,000 people. I really would like to replace Bob. I'm gonna be there with the simulator, so I'll be occupied, but if I could get someone
We got a 3x8 table, and I can get you all the table covers and all
to
that
help
stuff.
just to be there, we'll get a lot of foot traffic in our area. So it's a STEM event for like K through 5, I think. And what he said. Say Macomb Intermediate School District.
Yep.
So they have like well, they have a building that they do stuff at, and the event is at that building.
Yeah,
If
they've
you're
got stuff in
interested,
all the
I can
rooms.
get you the details.
It was a very cool event. I wish I could have left the table to see some of the exhibits and stuff, but I was kind of
Yeah,
like
they're gonna
table
have
bound.
drones and 3D printers and like we're not the main show. There's a bunch of other stuff going on, but and then Cranbrook the following Saturday, the 15th, they're doing their Leonid meteor shower event. They want telescopes. I think we've got 2 or 3, but we could always use more. So if you're at all interested, talk to me, talk to Bob, email info, email the board, any of that stuff works. And then I'll be talking to the lowbrows on the 21st if you want to check out my Gemini lecture, but it's out in Ann Arbor, so not everyone's very close. And then if you're just at all willing to help us with outreach, talk to me or Tina, because she basically does my job. All right.
All right. Publications, Vetchalia, anything? Anything going on?
What did you say? Okay. I know this is not working. So calendars are ready if you guys are interested, and newsletter is online. And also we are updating website. So if you guys have any suggestions or recommendations, bring them on. That's all.
All right. Yeah, I will get with you about light pollution. I definitely want to get a page up on that. All right. So yes, the newsletter is up. So if you need to contact the board, we are board@warrenastro.org. It's not on. So astronomy in the news. All right. Interstellar comet 3I Atlas. People have been getting pictures of it. I guess it just whipped around the sun. And I got to say, practically every article I see about this comet mentions a certain Harvard astronomer who shall remain unnamed with the claim that it's possibly alien technology. And this astronomer has said this for 2 of the 3 interstellar comets. I couldn't find a reference for Borisov, but when Vera Rubin comes online, it is estimated that it's going to find a lot of these things, and I wonder how many of these before you start looking foolish. How many of these are going to be alien probes? So yeah, a Fox Weather article today said gigantic interstellar comet accelerates and turns blue near the sun, and I'm like, Yeah, it's falling in toward the sun. It does that. It's called Newtonian mechanics. Yeah, but whatever. So that's my rant. Asteroid updates. We are at 1 million.
I think he already.
I'm
I
sorry.
think he already looks. I think he already looks foolish.
Yeah. No. I'm notice I'm not
Eh.
saying the name, but I agree. But I mean, it's just what it's 3 now. What if it's 50? Are they all gonna be probes? So anyway, asteroid update. We have we're coming up on 1,000,005. That's going to happen soon. Near Earth objects is we're coming up on 40K really soon. And on October 29th, asteroid 2025 UV7 passed within 0.26 lunar distances, and it's a 2 to 6 meter object. So it's probably discovered a day before it passed by us. We have over 6,000 confirmed exoplanets. That was crossed, the 6,000 was crossed a few weeks back. We have 7,700 candidates. We crossed 7,700 a couple days ago. And this week, the Exoplanet Archive added 15 new planets, including one 4 times as massive as the Earth, orbiting an M-class dwarf at an orbital distance that may support liquid water on its surface. So that's interesting. Let's see, can I share that? There was a can I get the whole thing? Yes. Share. So this was a coronal mass ejection that spit out of the sun yesterday, or no, that was this morning, and it lasted for several hours and hurled a big CME, and there's the big cool movie. So it was an M class, so it wasn't like one of the big nasty X ones, but still it lasted for hours. So if you're on Facebook, you can check out stuff like that and pictures of the sun at both CME alerts and the solar activity groups. Double stars, Riyadh, did you check out any double stars when you were doing your last outreach there at Stargate? I'm calling him back up. I'm sorry, Riyadh. Usually this works easier when you're online.
That's all right. That's okay. Yes, we did actually. We looked at a number
Awesome.
of double stars, including Alberio, which for a couple of new people that haven't seen it before, it was very interesting for them.
I remember it was not a double star, but I was out there and I was shown a carbon star, which I had never heard of, and that was pretty interesting.
Yeah, those are pretty red in color.
Yeah, that was really cool. So if anyone wants to start a special interest group like radio, which it seems like we have a radio group starting, yay. Computers, technology, education, light pollution, podcasting, whatever, just go ahead and do it and give a presentation about it and invite our members to join up. All right, so observing reports and astro photos. Do we have anybody that has anything they want to share? I see Doug going over to his mouse.
Yeah, we've had this couple of comets flying by here.
Yeah.
So I'll show you a couple of pictures
Awesome.
just a week or so ago. There we go. Where are we here? Share. Screen 2. And share. Okay. So this one is Comet Lemon taken on the 26th of October. It's about what did I figure? It was 75.
Wow.
It's my numbers are underneath there.
I'd love to see an animation of the tail over time.
Yeah, that's 76 frames at 30-second exposures. Taken with my 4-inch ALPO refractor in the observatory. And then on the
Doug,
yeah.
what are the transverse streaks Are those stars?
Yeah, those are stars.
Okay, thank you.
So obviously the comet's moving, during the period of time I'm recording the data. And I'm actually guiding on the core of the comet itself. So my scope is actually moving with the comet and not with the stars. I'm not guiding on the stars, I'm guiding on the core. So there's three ways you can do this. You can guide on the stars, take your exposures, and then stack on the comet. Or there's a delta value for both the RA and the DEC, the changing of the position of the comet over time. You can use those in PhD2 to automatically shift the exposure following the comet itself, or you can track right on the core of the comet if it's tight enough. So that's what I did on this one because the nucleus was.
I am seeing a blue tail, a white tail, and a yellow.
So this blue tail is the ion tail, and then this would be just the dust tail. And there might be two. There's obviously there's multiple streamers here.
Mm-hmm. That is beautiful.
And then on the 27th, I got this one. There's less time on this one though. This one I think is only. Actually, it's let me see here. This one's 75. About the same amount of time actually.
It looks like the coma, the green of the coma is spreading out near the top there.
We're right here, all people.
That is really cool.
You can look at taste the torture.
Now, I did take some earlier in the month. This would be on the 3rd, or maybe this was the 13th. No, this is the 3rd, when it was still in the morning sky. This one is also. So those are my 4 shots of the comet.
Very cool. Anyone else? Dale Homball's not online or not there?
Bob, there was a question from the room.
Oh, what do you got?
Can you hear me, Doug?
No.
They're making me get up here. Can you hear me, Doug? Can you hear me, Doug?
I can hear you.
Hello, Doug? I
Yeah,
have to look for him to hear me?
Yes.
Okay, did you see the comments without optical aid?
What did he say?
Did you see the comet without optical aid? No, that was all through a telescope, wasn't
No,
it?
I didn't. Not from my location here. I could see with my binoculars, but that was about it.
Okay, any other observing reports or pictures?
Give an observing report.
Incoming.
All right, so Diane and I were able to see the comet naked eye last weekend from Black River, or at least we're pretty sure we did. Sorry, this is Lemon.
Yeah.
The other comet, whose name is escaping me, Swan, we could only see with optical aid. And by the time we saw Swan, there wasn't much to see. But Lemon was really spectacular with binoculars and with the telescope. So hopefully it will still be around when the moon is finished. So I'm really hoping to see Comet Atlas. So fingers crossed we'll all get to see another interstellar object. That's it.
Yeah, I saw the moon on the way here, and as I turned around, it came back home. So, all right. If there are no other observing reports, we can get started with elections. So at this point, I can't help you.
All right, now let's do next slide. I'll be able to see that on the well, you set it there, I have to turn back. Yes, that.
No, he's gonna do that.
He'll do it. Okay, great. Good evening, everyone. It's that time of year where we have our annual elections for the 2026 WASP Board of Directors. Before I officially start the election with my sledgehammer, I would just like to take this time to say and recognize our outgoing officers and the board and the work that they did. So I think you should get a nice round of applause for serving with that group. Bob's doing his Cub Scout thing. Round of applause. Okay. The sledgehammer. The Warren Astronomical Society annual election of our board of directors for the year 2026 is now called to order. Next slide, Dale. Okay, and next slide. Okay, the bylaws, Article 4 for the Board of Directors, Section 402, the Board of Directors shall consist of 7 officers. Directors shall be elected by a simple majority of members present at this meeting. Section 4.03, directors shall be elected at the first regularly scheduled membership meeting in November of each year. Directors elected at this meeting will assume office starting January 1st, 2026. Next slide. Bylaws, Article 5, Section 5.01, the qualification of officers. You must be at least 18 years of age, must have been a member in good standing for 1 year, must maintain his or her membership in good standing during their term of office. Next slide. That's it. Okay, thank you. Tonight's election, this is the background and procedures we'll do to conduct tonight's election. The chairperson has received names of candidates willing to serve for the office of president, first vice president, second vice president, secretary, outreach director, and publications director. No nominations were received for the office of treasurer. Nominations will be sought for each office from the floor of the membership assembly. Nominations need not be seconded. Nominees will be asked if they accept the nomination. One may nominate themselves for any office during the election process if they are so inclined. After 3 calls for nominations from the floor, the chairperson will close nominations for that office. Section 5.02, candidates, that's election and term of office. Candidates running for any office uncontested will be elected by acclamation, which we will show of hands or applause. If the office is contested, a secret ballot will take place. The term of any office is for a period of 1 year, with no individual being able to serve more than 3 consecutive terms for the same office. And the duties and responsibilities of each board office are listed under Article 5, Sections 5.03 through 5.09 of the bylaws of this society. Okay, at this time, nominations are now open for the office of president. The president shall preside at all of the meetings of the board of directors, shall have other powers and duties as may be assigned by the board, and shall appoint committee chairpersons. Dale Parton, did you want to nominate somebody? Okay. A nomination from Dale Parton to he nominated Diane Hall to run for the office of president. Diane, are you willing to run for the office of president? She is. Thank you, Diane. Are there any other nominations from the floor for the office of president? Are there any other nominations from the floor for the office of president? And one final time, are there any other nominations from the floor for the office of president? Since there are no other nominations from the floor for the office of president, nominations are now closed, and by virtue of this nomination being uncontested, Diane Hall is elected president of the Warren Astronomical Society by acclamation. Good luck, Lawrence. Congratulations, Diane. Okay. Okay, at this time, nominations are now open for the office of First Vice President Program Chair and shall perform all the duties of the president in their absence or ability to serve. And as a program chair, very important position, solicit meeting presentations and guest speakers, planning and maintaining the presentation schedule, planning special presentations, communicating and coordinating with all meeting venues, and shall be a member of all committees appointed by the president. Madam President, is anybody like to nominate? Jonathan Cade, are you willing to accept the nomination?
Only with great.
Okay, that's it. Okay, so with great trepidation, Jonathan accepts the nomination. Are there any other nominations from the floor for the office of First Vice President? Are there any other nominations from the floor of the First Vice President? And one final time, are there any other nominations from the floor for the office of First Vice President? And seeing that there are no other nominations from the floor for the office of First Vice President Program Chair, nominations are now closed, and by virtue of this nomination being uncontested, Jonathan Cade is elected First Vice President Program Chair of the Warren Astronomical Society by acclamation. Congratulations, Jonathan. Condolences. Okay, we'll make that amendment in Robert's Rules of Order. How's that sound? All right, next slide. Nominations are now open for the office of Second Vice President Observatory Chairperson. The nominating committee has received the name of Riyad Mahdi to run for the office of Second Vice President Observatory Chair. Riyad, are you willing to run for this office? Okay. If he is elected, this will be his third consecutive term serving for the office of Second Vice President Observatory Chair, and he has accepted the nomination. Are there any other nominations from the floor for the office of Second Vice President? Any other nominations from the floor for the office of Second Vice President? And one final time, are there any other nominations from the floor for the office of Second Vice President? Since there are no other nominations from the floor for the office of Second Vice President, nominations are now closed, and by virtue of this nomination being uncontested, Riyad Mahdi is elected Second Vice President, Observatory Chair of the Warren Astronomical Society by acclamation. Congratulations, Riyad. Nominations are now open for the office of Secretary. The nominating committee has received the name of Charles Strackbine to run for the office of Secretary. Charles, are you willing to run for this office for the office of Secretary?
Yeah.
Okay, Charles has accepted to be nominated to run for the office of Secretary. Are there any other nominations from the floor for the office of Secretary? Are there any other nominations from the floor for the office of Secretary? And one final time, are there any other nominations from the floor for the office of Secretary? Since there are no other nominations from the floor for the office of Secretary, nominations are now closed, and by virtue of this nomination being uncontested, Charles Strackbine is elected Secretary of the Warren Astronomical Society by acclamation. Congratulations, Charles. Next slide. Okay. Nominations are now open for the office of Treasurer. The nominating committee has not received any names of candidates to run for the office of Treasurer. Are there any nominations from the floor to run for the office of treasurer? Are there any nominations from the floor to run for the office of treasurer?
I nominate Jim. Last name, but not all stuff.
Jim? Okay, so you're going to decline. Okay. Understandable, Jim. Are there any other nominations from the floor for the office of treasurer? And one final time, are there any other nominations from the floor for the office of treasurer? Since there are no nominations from the floor for, after calling for the third time, the office of treasurer is declared vacant and the board of directors will seek a volunteer or person interested. It must be a member in good standing to fill this position. Next slide. Nominations are now open for outreach director. The nominating committee has received the name of Jeff McLeod to run for the office of outreach director. Jeff, are you willing to run for the office? Okay, thank you, Jeff. He's willing to run. If he is elected, this will be his third consecutive term serving in the office of outreach director. Are there any other nominations from the floor for the office of outreach director? Are there any other nominations from the floor for the office of outreach director? And one final time, are there any other nominations from the floor for the office of outreach director? Since there are no other nominations from the floor for the office of outreach director, nominations are now closed, and by virtue of this nomination being uncontested, Jeff McLeod is elected outreach director of the Warren Astronomical Society by acclamation. We closed them. The next slide. Nominations are now open for the office of publication director. The nominating committee has received the name of Vachalia Dandibatla to run for the office of publications director. Vachalia, are you willing to run for the office of publications director? Oh, thank you. Okay. Okay, Vachalia has agreed to run for the office of publication director. And if she is elected, this will be her third consecutive term serving in this office. Are there any other nominations from the floor for the office of publications director? Are there any other nominations from the floor for the office of publications director? And one final time, are there any other nominations from the floor for the office of publications director? Since there are no other nominations from the floor for the office of publications director, and by virtue of this nomination being uncontested, Vachalia Dandibotla is elected publications director of the Warren Astronomical Society by acclamation. Yeah. Congratulations. Yeah, next slide. And one time, congratulations to our elected officers of the 2026 WASP Board of Directors. Do we have a motion to close and adjourn this meeting? Okay, Dale Parton.
Seconded.
Who seconded? Okay, Jonathan, got that. Dale Parton, Jonathan second. All those in favor signify by saying aye. Okay, next slide there. Okay. The selection meeting is now closed and adjourned. And thank you for attending this meeting, the important meeting to elect our officers. Next slide. And now it's snack time.
Yes, it is. All right. Thank you very much, Mark. And thank you, everyone who has a new position. All right. So then I have my notes here saying 8:15 for the feature talk, but that's a half an hour from now. Do we want to do what, 20-minute snack break, you think? Reconvene at 5 after?
20
Okay.
minutes on.
20 minutes. Timer. I wish, does this thing have a timer? So reconvene at 5 minutes after 8 o'clock, and we will have our feature presentation. There needs to be a timer app on this thing. Actually surprised there isn't. So yeah, I was on my way to Cranbrook, and my car started having trouble, so I turned around. So I've got all the munchies that I was gonna bring to the meeting. So thank you, Dale, for picking up munchies. And look at that. It does have a timer. I did not know it did that. 3-minute warning. So Rick, what's Delores doing now that OSIRIS-REx is wound down?
Gee, Dolores, what are you doing now that OSIRIS-REx is wound down? He just asked.
We're still furiously analyzing samples.
They're analyzing the samples,
Mm-hmm.
and that's going to probably take a couple of years more, I would imagine. She's sitting right over here. Doesn't want to be on camera.
That's okay. Well, let me tell you, when I went out there for the Faith and Astronomy workshop, and we saw the OSIRIS-REx and that huge meteorite collection. That was just fantastic.
Yeah.
All right, so
It's to drool over.
stopping my timer. All right. 2, 1, 0, and there goes my timer. Time's up. All right, so we are back at the meeting of the Warren Astronomical Society, our feature presentation. But before we have our feature presentation, I would like to extend an acknowledgement and thanks to our many volunteers who work events and tirelessly and sometimes freezing their niblets off at some of these events. But thank you everyone for all the work you do at these events. And now Dale Parton will introduce our feature presentation. You are muted, Dale.
Thank you, Bacchalia. What would we do without you? Some people could manage, not me. Okay, Rik Hill attempted to give us his presentation, I don't know, 2 or 3 months ago. And we had some audio-visual difficulties, which hopefully we've got ironed out.
August.
August it was? Man, tempus fugit, time flies. Anyhow, Rik Hill got started early on his astronomical career. He was 7 years old when he observed Mercury transiting the sun. He's got to give us a show too, I see. He continued observing through the 1960s, first with a 2.4-inch refractor, and later with a 6-inch reflector telescope, which he bought with money earned from mowing lawns and washing cars. Boy, does that bring back memories to me. In the Navy, later on, as a radar technician, he helped navigators identify stars and participated in the Atlantic backup recovery for Apollo 8. That goes back some more. After his discharge from the Navy, he sold his 6-inch telescope to a local high school girl who later invited him to help establish an astronomy club. They got married in 1974 and have been together for over 50 years. That's pretty impressive. So Rik got involved with ALPO, which stands for the Association of Lunar and Planetary Observers, where he founded the solar section. He also became a member of AAVSO, the American Association of Variable Star Observers, and co-founded the Sunset Astronomical Society in Midland, Michigan, with his wife, Delores. He worked at Kitt Peak National Observatory in Arizona for 12 years. He worked at the Lunar Planetary Lab at the University of Arizona and on the Catalina Sky Survey, discovering thousands of asteroids and 27 comets. That's a bunch. Before retiring in 2015. Now he focuses on astronomy from his home observatory while caring for bonsai trees and fostering rescue cats. Wow, man of many talents. So his title tonight is Cycle 25, Where We've Been, Where We Are, and Where We Hope to Go. Rik, take it away.
I will, and I guess I'll just say next slide when we need it. Dale?
What?
We're all set.
We're good.
We're on first slide.
Okay, somebody's going to hear me anyway. We have high technology here. I do not have control of my slides. So what we're going to talk about is cycle 25, sun cycle 25, solar cycle, and where we are and where we hope to go. Where we've been, well, it's pretty much everything's behind us on this cycle, as you will see as we go on. Next slide. The obligatory warning with all solar talks is that solar observing is the only intrinsically dangerous type of observing for amateur astronomers. You must always use filtration, proper filtration. If you're not sure you've got the right filtration on a telescope or even just looking up at the sun, don't do it. You get one mistake, that's it. So go ahead to the next slide. Now, the sun was described to me by one of my mentors, who's Jim Loudon. Some of you may have heard him. He died in 1988 at the tender age of 44. And he gave lectures all over the Great Lakes area. And he and I were good friends. And he used to say the sun is 5 things. The sun, or any star for that matter, is a very big, very bright ball of glowing gas. It's a beautiful, succinct description of a star. And it's very true. Next slide. Now, this is what our sun looks like if you could cut it apart and look at it. The innermost part of the sun is the core, and where all the nuclear fusion goes on, and the heat from that percolates up through the convection zone. The convection zone is where we have rotating ropes of magnetic flux. And as the sun rotates, those ropes get twisted and twisted until they pop up. They form loops, like when you twist your garden hose and it pops up. And where it pops out of the solar photosphere and pops back in, those form the two parts of a sunspot, the leading and following spot. And they will have magnetic polarity depending on which part of the rope popped out and went back in. And every 11 years in the sunspot cycle, they switch that polarity. And in the one hemisphere, the polarity will be maybe the leading spot in the rotation will be positive, and in the other hemisphere, it'll be the negative and the leading spot. So this is in the photosphere, the part that you can see with your eye, or with, like I say, with the filtration. The photosphere is simply the area where the gas got cool enough and dense enough so it actually formed what looks like a surface. Actually, there is no real surface to the sun. Next, please. These are the three main colors that people observe the sun in, and they each represent a different element. The photosphere of white light up in the upper right is what most of us have with our sun filters, and it's what most amateur astronomers observe in, and we get most of our observations in that. And then second to that is H alpha, or hydrogen, which is the orange over on the left, and that is very popular, and there's a number of companies making telescopes for that now. And then at the bottom you see the purple, or the calcium, and calcium is way over in the blue end of the spectrum. I can no longer, these colors are all faked in. These are not real colors at all. The H alpha is a deep, deep red. You can hardly see any detail in it with your eye. And the calcium, if you're young, you can see the calcium. If you're my age, calcium's gone. I can't see that end of the spectrum anymore. And that's true for most of us that get up in our 70s. And it's just the way it is. And we image these things, and then we can see them in the images. I love digital astronomy. Next, please. This shows what is the sunspot cycle. What are some manifestations of it? The top graph is called the butterfly diagram. Sunspots, when they form at the beginning of a solar cycle, form closer to the poles, usually plus 30, minus 30 degrees. And as the cycle goes on, the sunspots form closer and closer to the equator. Right now, if you look at the sun, the sunspots will all be forming near the equator. And so this is what you see here. But the interesting thing about this is you'll notice that the ones forming at the equator are not quite gone when the ones forming near the poles are already starting up. And that's where we are right now. We're telling observers to be on the alert for new cycle 26 sunspots, because they're going to be coming any day now, and also be on the alert for days of 0 sunspots, because that's going to start happening soon. The middle diagram shows the sunspots measured by area, which is pretty much the same as just counting the sunspots in terms of how the graph looks. And you can see that there's every 11 years it reaches a peak and goes back down. It's not exactly 11 years. Some sunspot cycles are 10 years. Some of them are 12 years. The sun is a messy object and doesn't conform to what we like is our clean beginning and endings of things. Now you see the last one on the right, that last cycle is very weak. Our cycle that we're just finishing now, that's cycle 24. Cycle 25 that we're finishing now was almost that weak. And it was indeed stronger by a little bit. At the bottom, you see all the sunspot cycles since the beginning and stopping at the end of cycle 23. The cycle was started, the numerology of the cycles was started in 1825 by Heinrich Schwabe, who observed sunspots with a 4.5-inch refractor and started notice the cyclic nature of the sunspot's appearance. And they went back and with old observations going back to the beginning of the telescope, they were able to accurately note solar cycles back to around 1750. And that has kept on ever since. We're going to show you some other cycles too. Next, please. I'm going to wet my whistle. Now, this was back in about 2010, 2012, somewhere back in there, that William Livingston and Matthew Penn, both of them I know. William Livingston was an astronomer at Kitt Peak in the solar division, and he was one of the mentors of the solar section of the ALPO. Matthew Penn, I still know. We communicate on Facebook from time to time. William Livingston is still around too, but he's getting up there in years. He's getting close to 90, I think. And they made this prediction that sunspots would vanish by 2015. Oops. One thing you can be guaranteed of with predicting anything about the sun, it's going to be about as accurate as a weather forecast. And you're more than likely going to be wrong. Next, please. Here's another prediction. It was going to be the strongest sunspot cycle on record. And it wasn't that either. And the next one. This one predicted 2 extreme solar flares stronger than X14.3. I'll talk about that in a second when I can show you more about solar flares. Next, please. And then it said this could be one of the strongest on record. So you had everything in the predictions from the strongest on record to no sunspots at all. Those predictions were all out there. And so I just told everybody, why don't we just watch and see what happens? Next, please. Now, this shows the solar flares. This is from the spaceweather.com list of the top 50 flares since June 1996. And these flares that I have listed here are just the ones from the solar cycle 25. And there's nothing even, each one from X9 to X10 would be 10 times bigger, just like the Richter scale. From X9 to X8 would be 10 times weaker. So, sorry for the cat in the background. So this scale is very much like the Richter scale. So an X14 would be 10 to the 14 stronger than what you see here. And you see down at the bottom, the strongest one was X40. And that was measured by a satellite. And when that satellite measured that, they say X40 plus. They don't know the true full value of that flare. The satellite was burned up by the flare. Now, am I still getting through? Oh, good. Okay. I wanted to check because the last time I got to the end of the talk and nobody was hearing me. Next, please. Now, this shows the solar cycle as we currently have it. These are the last, 8 cycles. But you see the cycle we're in, it's unfinished. What you see after that, that purple little wing on there, that's the prediction envelope. You'll see a little spike that goes down quite a bit. There's one that goes way up at the peak, and then one that goes down quite a bit. That was back in April, May of this year, and that caught us all by surprise. We didn't know what to think. The sunspot count went down to 78, and that's very low for that point in the solar cycle. It came back up, but as I'll show you on the next slide, it didn't come back all the way. Go ahead. Oh, I just got to show you this first. This shows dramatically how the sunspots at the beginning of the cycle start near the poles, up at the top and the bottom extremes. And as they go further and further into the solar cycle, they move closer and closer to the equator. They didn't show you all the sunspots. If they had done that, this would be black in the middle. But it showed you some of the more interesting ones. Next, please. Now, this is the last cycle, about the last 2/3 of the last cycle, and the current state of affairs with the current cycle. You can see that spike that points way down that happened back in April and May. It came back up, and we got all hopeful that it would keep coming and we'd have a second hump. I'll show you that second hump in a second, but it didn't. It came back up and went right back down, and it's on the lowest. Those 2 dashed lines are the predictions for what the cycle will do, and it's staying down near the lowest prediction. We are pretty much finished with solar cycle 25. There will still be some nice sunspots and good ones to photograph, but the big activity is probably over. Next, please. This shows a number of solar cycles, about the last 15, but the important ones are 21 through 24. Notice they have double humps. That's what we were hoping for with this cycle. But notice also that the minimum in between the two humps is migrating backwards in the cycle, and it may have migrated completely off to where we won't even get that second hump now. In fact, it's a pretty sure thing that we won't. Next, please. Now, this shows a number of solar cycles back to the beginning in 1750. That's as far back as with observations recorded in astronomers' notebooks that we can rely on. Then it goes back into 1700 to 1750. There's some observations, but there's the Maunder minimum. And there's still quite a controversy about the Maunder minimum on whether that's really a minimum or just people didn't observe the sun. We have every reason to believe they did this, or they did observe the sun. We can name the astronomers, in fact. But there appears to have been little or no activity at that time. The Dalton minimum is another one. You see another minimum over there around 1900, not as strong. And we may be into one right now, as a matter of fact. Next, please. This is Heinrich Schwabe's drawing with his 4.5-inch telescope. These are not the number of sunspots in those groups, but actually he numbered the sunspot groups themselves. And that's what you see here. Next, please. Now, the cycles going back to 1700 seem to have, and this takes a lot of smoothing to
cheaper to come down. But we have 3 children, and the most important thing I think that all 3 of our kids express and really stand for is it starts right here.
Hey, Ken, can you mute your mic, please?
Give people the respect like you want to have the respect. And if we do that as parents, that's our mission. That's our goal.
Are we okay?
Yep.
Okay, well, what this shows is a severe smoothing of the sunspot cycles, which brings out this sinusoidal waveform that may or may not be real. This is a controversial thing, and they're calling them the Gleisberg cycles and the Schwab cycles. Next, please. This shows an even stronger cycle correlation, which you got the modern maximum, which may or may not be a maximum. I mentioned that earlier. But then we go down to the Maunder minimum and the Sporer minimum and the Wolf minimum. And well, where did they get this? There were no astronomers observing the sun. Notice on the left side it says C14 level in the atmosphere. This is C14 measured from tree rings. Tree ring research done here at the University of Arizona by A.E. Douglas, started by A.E. Douglas. The tree ring lab goes on. But this is what they have gathered from tree rings using C14 levels. And it looks pretty good. It correlates well with the observations done in the modern period. So we feel fairly confident of this, and they're going back even further now. They've gone back as far as 14,000 years, though people argue about that a lot. That's pretty far back. Next, please. So here's cycle 25 again, and we see at the top, you see the little notch from April and May, and then you see the envelope, the purple envelope, and we're definitely tracking on the low end of that envelope. This is from National Oceanographic and Atmospheric Administration. And down below is the 10-centimeter radio observations. And that ditch in April and May isn't quite as deep in the radio. But then again, it came back down, and it's even lower than the predicted envelope. And it's showing you that predictions are fine and all that, but they can't be relied on. They are just predictions, like a weather forecast. Next, please. Now this looks pretty squirrely, but let me take you through it. The main line that you see up top, the smooth line, is the 81-day 10-centimeter flux line, and it shows that we're going downhill. All of these show downhill trend, and that's what the important part of this is. The black line in there that's really raggedy is the 10-centimeter solar flux as it was measured, and then we have the NOAA number on top of that in red, and but they're all trending downhill. And this is why we think we may be over with this cycle. Next, please. This one it'll be even more convincing. These three different colored lines are predicted solar activity. And the blue one would have been the double hump if this had followed a double hump of the previous 4 cycles. It would have done that, but it didn't. It's down on the red line, which is the 5 percentile confidence line. So it's pretty down low on the predictions. And I would imagine we're going to be seeing some new predictions made very, very soon from places like CILSO in Belgium. I forget exactly what CILSO stands for, but it's the solar observatory, solar observatory in Belgium. And they do one prediction, then the NOAA and space weather do another prediction here in the United States, and the AAVSO does their own too as well. Next, please. This shows a 10-centimeter flux. You can see the blue line. The upper one shows the double hump prediction. If that had happened, it didn't. In fact, their line shows that they're below the 5 percentile, which is not boding well for solar observers. We like to see it a little bit higher. Next, please. Now, this is a small sunspot. That's the Earth to scale. Now, there's a measurement that we use for sunspots. This one's a very small one, probably not capable of producing any flares. And we use a scale where we measure them in millionths of the solar disk. And for a long time, I tried to figure out what's a millionth of a disk. Who's got the scale for that? I mean, is it kept in Paris with the yard and the meter? I didn't know. And finally, it just dawned on me when somebody happened to mention that there are 1 million granules. These are granulations. And there's 1 million of these granules on the disk at any one time. And it struck me, that's what they're using. That it's the average size of a granule is 1 millionth of the solar disk. And so there you see a bunch of millions, and you see a sunspot group that's only about 20 millionths, maybe 30 millionths in size. There's a leader spot with penumbra around it. That's the fuzzy stuff. And then there's a follower spot that's just kind of a snaky looking thing. There's other spots above and below, but those aren't spots, those are pores. They're not dark like a sunspot. If this was better scaled, the exposure on this, you would see that they're not dark. And they can become sunspots. They can be the beginning of a sunspot, but not in this state. And you'll notice that the granulation changes in its form around the sunspot. That's very, very common. Next, please. Now, this is a small, I said small sunspot. It's only about 40 millionths, maybe 50 millionths in size. You'll see some that are much bigger than that. But notice that's the Earth to size. Even a small sunspot would swallow the Earth. The Earth is very small compared to the activity we're seeing on the sun. Next, please. Here's a fairly large sunspot, 1,280 millionths And this one, it takes about 700 millionths for the average young person to see a sunspot with a solar filter. Mind you, with a solar filter. Always. Solar, by the way, solar eclipse glasses are a good thing to use too. But you can see this with the naked eye quite easily at 1200. Even I can do that. And my eyes are scarred from retinal surgeries and cataract surgeries. So, and still I can see one this size. Next, please. This is what it looked like in H alpha. Notice the bright regions down below the sunspot. We couldn't even see that in the white light. And the bright regions in between the two spots, the leader and the follower spot. And those are areas where are good for flares. And that's where you should watch for flares. And I try to encourage people to look for white light flares. We used to have a program to do that. We saw plenty of them. White light flares are a lot more common than the old books would have you believe. Next, please. This is the same group in calcium. And you'll notice the bright region around the spot in the back, there's some little bright points. Those bright points are called Ellerman bombs, and they come up and fade away very quickly. And so if you can catch those, you're doing very well. There's possibly one in the leader spot on the south edge of the leader spot. But the big bright area that they sit in is called a plage. And it very much mimics faculae, the bright stuff we see when the sunspots are on the edge of the disk. Faculae and plages are very similar in area and position. Next, please. Here's another big one. This is 1450, a little bit bigger. Nice big umbra on this one. This one would be very easy to see. The more condensed it is, the easier it is to see. You can have a sunspot that's several thousand millionths of the disk, but it's spread all over with smaller spots. And it's very hard to see with the naked eye. But this one, you can see granulation in this image, and it's got a lot of cracks in the sunspot. Those cracks are good places to look, and those little separate spots in between are good places to look for flares as well. Next, please. Here is an H alpha, and you can see just south of this spot, beautiful cracks in that sunspot where those flares can flare up and pop out, and in between those spots where all those little spots were. Notice the swirling nature of the filaments around the sunspot. Those are not coming out of the sunspot, they're going into the sunspot. The material falls into the main umbra of the sunspot. Even that material down south there, on that big dark filament, it's falling into those smaller spots. If you could do a movie of this, it's amazing to see how this material falls in. Next, please. Here it is, that same sunspot group in calcium. And you can see the bright area south of the big spot where it's possible you get some flaring there. There's no obvious Ellerman bombs in this one, though. Next, please. This is a very large spot. This one was 2,400 millionths. This you couldn't not see this one if you look through your solar filter. Just taking your solar filter off your telescope, if you have a visual filter, and holding it up is good enough. But eclipse glasses, like I say, work very well too. Next, please. There's another picture of the same one done in calcium. It's an off-band calcium, not like the calcium you were looking at. And this is done by Christian Villadrich in France. He does fantastic work. You'll see some more in just a second. And this was an amazing sunspot group. I took many photos of it. Next, please. Here's his H alpha, or no, this is actually calcium, but he's got such a narrow band on the calcium, it looks like H alpha. You can tell this is calcium by noticing the big islands on either side of the sunspot group. Those are called macrogranulation, and you only get that in calcium. But this is during an M2 flare. This is just an M2 flare, not even an X flare. X flares sometimes, they're so bright you can't see the sunspots. Next, please. Now this is Howard Eskildsen. He's over on the East Coast of Maryland, and he does his same scale at the same time, well, within an hour. And we can put his images together. He hasn't put them together like this, but I do when I do the reports. And so this is a very nice image here that he has showing the sunspot group. This is actually 4 sunspot groups, 3 in the arc, actually 5, 3 in the arc, 1 above, and then 1 way off to the right. And you can see that the one farthest to the left is the most active, and there's a fair amount of activity in the one in the middle above. And you can see that in the H alpha. And in the calcium, you can see that it's brightest on the one on the right. And those would be the ones you would watch. The way to do it is to sit on these groups in H alpha or calcium and keep your white light scope on it too. But watch in H alpha or calcium, watch for the flares every 10, 20 minutes during the day. And when you see it brighten up, when a flare is happening, check it in white light for white light flares. Check it in calcium for the calcium flares too. And you'd be surprised how many you catch that way. Next, please. I keep trying to advance it here with my keyboard. This is another sunspot group. This shows something that's very common. And that is, you see up top, there's 2 or 3 groups over on the edge of the sun, the limb of the sun. And there's one group over near the middle. It's isolated all by itself. It's relatively inactive. And then down in H alpha, you see a lot of things you can't see in white light, like the bright region to the left of that isolated one. You can see several bright regions in the ones on the limb. You got that nice big dark filament in the middle. They don't move a lot. They don't change a lot. They will be much the same day to day. And but the sunspot groups in the bright regions of plages, they change a lot. And then you see down below, there's a flare. He caught a flare in calcium that was just starting up in the H alpha. And if he had stayed on it and kept photographing it, he probably would have caught the whole evolution and decay of the flare, which would have been very interesting. We highlight that in the solar reports. In fact, that's why I'm giving the talk now, and I couldn't do it in September. And for the entire month of October, I'm writing a solar report. I have to prepare in September, and for all of October, I take the deep dive into the quarterly report, and I can't do anything else. Next, please. Here's a fellow we have in Malaysia. He's doing white light on the left and H alpha on the right. And you can see that at the same time he does that white light, well, it's not exactly the same time because he has to change filters. If you have, I've got 3 separate scopes, so I can actually do these things simultaneously. But he's caught a flare in H alpha. I know it's not red. It, like I said, doesn't matter. This is all false color anyway. And he's got some very good detail in these. Plus, you can see something here that I really enjoy watching. See the hairiness to the edge of the sun in H alpha? Those are called spicules. They're little tiny, like little flames coming off the sun. If you watch those, if you take a picture every minute for 10 or 15 minutes, and then make a movie out of that, you'll see those jump up and pull back and jump up and pull back, just like the candles on a birthday cake. It's fascinating to watch that. Next, please. Now, here's another one, just like the previous one we saw, where we got 4 sunspot groups in a row, one down at the bottom on the left. There's another fairly large one on just right of center, another one very on the right edge, and there's an isolated spot in the middle. That's separate, that's 3839. And the one on the left is 3842. The one to the right of 3839 is 3844. And the last one on the right is 3843. This is something we have to do in the solar sections. Keep track of all these things. What are they doing? Are they decaying? Are they growing? And it's with all the help of these amateurs around the world that we are able to track this stuff. In fact, right now, I'm looking for if you know anybody, I'm looking for amateur astronomers in Hawaii that observe the sun. We desperately need that longitude covered because we're missing a lot of flares that happen. They peak while the sun is over the Pacific Ocean, and nobody's catching these right now. And there have been some big flares. Next, please. This is one of my images of that one of the groups in that string, and you can see that the granulation here, and you could if you wanted to measure it by taking a certain area of the sun, counting the number of granules in it, and using that as your yardstick and measuring the sunspots. But then you have to take in account how much they measure. Because they measure this for all wavelengths and for the whole area. That includes any plage. So it's a tricky business, and we just take the numbers that are put out by Space Weather as gospel and go with that. Next, please. This is a picture by Randy Tatum in Virginia of a sunspot group, one of the ones we were just talking about, and it's on the edge of the disk, about to go around the edge of the disk, and he does this with a 7-inch refractor, spectacular resolution. And you can see the faculae, these white crack-like riverlets that run in between the sunspots. And if you could see this in calcium, you would see those in calcium, just the same way. And he's using a Botter filter here and a UV-IR filter and a 2X Barlow on an F15 refractor. F30 is very commonly where you want to work with solar work, to F20 to F30 if you want to get the detail. Next, please. This is his picture of the same sunspot group, but this is an H alpha. Again, you can see the spicules on the edge of the sun giving it that deckled look. And these what's the name for them? I'm drawing a blank at the moment, but this is material falling into the center of the sunspot. The material is carried up into the corona. And in the corona, it's so hot, you can't see it. It's not visible. As it cools and comes down and starts to fall, that's when it becomes visible, falling into the sunspots, and it makes a heck of a show.
It's called coronal rain.
Yes, thank you. And I'm sorry that he hasn't taken any videos of this. I wish he would. It would be well worth his time. So go to the next slide, and we'll end up here. Oh, I forgot. This is with my little 40 millimeter PST telescope, where I caught a flare here, an X1 flare, and you can see that this is what, 20 minutes, and it's decayed away that much in 20 minutes. These flares change rapidly, but a 40 millimeter telescope is perfectly fine for catching these things and noting them. And I would recommend this to anybody. Next, please. Okay, well, wrapping up, this is my email. If you want to know more, you want to get involved with the solar section of the ALPO, you can go here, contact me. I'm on Facebook as Richard Hill, not Rik Hill. I should probably change that. But I'm on Facebook as Richard Hill, and I have a lot of astronomy there. And right now, most of it's comets. Next, please. And my website is offline, like it said there. I'm sorry about that, but when I first retired from the university, they changed my email 3 times in 3 years. So I had to get a separate email, so I had a stable email. And then last year they said, "Oh, surprise! By the way, we're taking all you retirees. We're taking your web pages off too." And so they just threw us out into the wild with the wolves. And so I'm rebuilding a website, but it's going to take a while. This is the Solar Section website. I highly recommend you go there for more information. And I don't know what the next slide is. Okay, that's it. We're done. Thank you. Any questions? I'd be glad to take them.
But,
Really?
I just wondered if you could expand on the tree ring and the carbon-14. How does the sunspot actually affect the carbon-14 in the tree ring?
I don't know exactly how that's put in the tree ring, built into the tree ring, but it's from flare production. It happens through flare production, and I don't know more than that.
Okay, thank you.
Oh, hold it. I have an expert over here telling me. What is it?
It incorporates the carbon dioxide in the atmosphere.
Incorporates?
In the tree.
My wife, who works with this kind of thing, says it incorporates the carbon dioxide in the upper atmosphere, and that gets captured in the tree as the tree grows.
Oh, good. Okay, thank you.
You can imagine what our dinner table talk is like around here.
I have a question, Rick.
Yeah.
Does this mean we're not going to see any more auroras for the rest of this cycle?
No. You can be surprised. The sun surprises a lot. And we could have a 3,000, 4,000 millionths of a disk sunspot form tomorrow and start popping off X flares, and then you're going to get your aurora. The X flare that produced the aurora way down, we even saw it in Arizona here. That was the X9 flare. Not by far, not the strongest flare we ever had. The strongest flare in recent memory was, oh gosh, now I got to remember, it was back in the 1980s, and it shut down the Ottawa power plant. It was an extremely powerful flare. If we had one like that now, all bets are off on what would happen. We've not had any strong flares with all these cell phones and televisions and everything, all these electronics. They're not hardened. The military is starting to get wise and hardening some of their electronics with putting a lot of stuff in Faraday cages. But the average person carries their phone in their back pocket, and that's not a Faraday cage, trust me. And if we have an X14, an X15, or an X40 flare, we could put the whole planet in the dark. So it's we don't know what's going to happen. There's a lot of papers and even books being written about that. I highly recommend them. They're fascinating reading, especially if you like doomsday scenarios. Any other question?
My wife is reading a book by Nora Roberts.
That name's familiar.
Yeah, it's concerning a solar flare causing the downfall of civilization. So yeah.
An X40 flare. I can't imagine what would happen today if we had an X40 flare.
It would induce a current in every wire on the planet.
And satellites. Yeah, a lot of those Musk satellites that are going up there.
Popping like popcorn.
We might have some beautiful meteor showers. So it could get really interesting. So yeah, that can happen. The sun can do this. We don't know why. There's a lot of people studying why. There's a lot of people writing books why it happens. Almost all of them are wrong. And eventually we'll know. But the results from the Parker Solar Telescope have been remarkable, and that's going to refashion what we think about all of this. Anybody else?
Questions? Okay, let's thank Rick again.
This is what an old vice president of War and Astronomical can do with himself. I was vice.
We'll see you guys at Macomb.
All right, so our banquet is Thursday, December 4th coming up. The next meeting will be November 20th at Macomb Community College. Next star party is 2 days after that, November 22nd, and several of you will meet at the Redcoat Tavern at Woodward, north of 13 Mile, for gastronomy after astronomy. I was going to be there with you, but unfortunately I won't be tonight. So with that, the meeting is over. Good night, clear skies, and safe travels, everyone. Good night.
No one signs up as treasurer, we're gonna have ChatGPT do it. No one wants that.
Yes, we will get ourselves a treasurer. Thanks, Rick. Appreciate it. All right. Night all.